Jamb candidates, please grab your pen and your paper to jot down whatever you understand in this lecture, because you are definitely going to need it 3 weeks from now for your revision. So no snooze, so that way you don't lose. So before we start with this chemistry lesson, if you need this short, concise lesson note straight to the point, the full syllabus, that big Jamb syllabus, I compressed it to 350 slides, small slides, just like what you see for your screen, for your consumption. As you read them, they enter your head. Don't be all those boring, dry textbook and all those things. No, I don't stress students. So if you need it, come to my DM, send message, make I help you pass, okay? So that I will give you a copy of this short, concise lesson note. All right, without wasting much time, let's head straight into the nitty-gritty of today. And the nitty-gritty of today is what? Carbon and its compound. All right, carbon and its what? Its compound. All right, carbon and its compound. Before you treat the carbon and its compound, before you explain the carbon and its compound, you are supposed to talk about the allotrope first, because the allotrope of carbon is very important. Those allotropes of carbon, they are very important. Yes. Just like the one of sulfur, where we treated sulfur, rhombic sulfur, monoclinic sulfur, plastic sulfur, and so on and so forth. They are important. So before you treat their compounds, you treat them first. Let's go. The allotropes of carbon include diamond, graphite, charcoal, fullerene, and carbon nanotubes. All right, let's look at diamond first of all. Diamond is the hardest natural substance on earth. And what is the shape of diamond? What is the shape of diamond? Do you know the shape of the molecule of diamond? Diamond molecules are arranged in crystal lattice. Okay, the diamond is arranged in an octahedral form. Octahedral. So that's the shape of diamond. Octahedral. So when you say octahedral, it means 8 shapes. Oct means 8. All right. So 8 shapes. So diamond has 8 shapes. It's octahedral in shape. All right. And diamond is a transparent material, and it is a non-conductor. It does not conduct heat nor electricity because it has no mobile electron in it. Remember, it's very hard. What are the uses of diamonds? Diamonds are used as a cutting tool. Only diamond can cut diamond, and diamond is also used to cut glass. It's also used to cut metals. Okay, diamond is also used as what? Jewelry. See my eyes. Oh, you gotta start. Oh, we're gonna say you're gonna want to concentrate. I heard wish you got a water flush. Amigos. Right? So all those things where they display, okay, all those diamond teeth. That's it. Okay, it's used for what? Jewelry. Okay. Now let's look at the next allotrope of carbon. Very easy. Graphite is the next. Graphite, unlike diamond that is hard, and transparent. Okay. Graphite is soft like bread. Soft like bread, like baby nyash. Okay. Not just like bread. You can also say it's soft like baby nyash. Okay, it's also black. All right, black. Unlike diamond that does not conduct electricity because it has no mobile electron, graphite conducts electricity. Okay, graphite also have a form of bond in it. The molecules of graphite are held together by a force called van der Waals intermolecular force. All right, so it's a weak intermolecular force. Okay, so that's what holds the molecules of graphite together. Because of this, you know, the way the molecules of graphite easily slides between one another. That's what makes graphite a solid lubricant. So graphite is a solid lubricant. Okay, it's a good lubricant that resists high temperature. Okay, that's why you use graphite in a place where the temperature is very high and you need proper lubrication there. Graphite is a perfect fit. Okay, graphite is a perfect what? It's a perfect fit. All right, so that's that for that. All right, so let's look at the uses of graphite. Graphite is used as electrode during electrolysis. Do you know the electrolytic process where graphite is used? Anode is what? In electrolysis, anode is known as the positively charged electrode. All right. So is graphite supposed to be the positively charged electrode or negatively charged electrode? Graphite is supposed to be the negatively charged electrode. So which electrolytic process is graphite used as the cathode? Drop it in the comment section, my scholars. All right. Let's move over to the next. It's used as what? Lubricant. It is also used to make pencil. You know that it's black. Unlike those days that they used to use lead pencil, they used to use lead to do pencil. They later discovered that lead is very, very poisonous. Very, very poisonous. And small picking, they chop pencil. You see that black thing where they say pencil? I don't think count how many times I chop and when I be small picking. While I was little, I can't remember how many times I ate that black thing inside pencil. Now God help me. Thank God say during that time, don't be lead pencil there. If I was saying lead pencil, I for don't die quickly. So we also use graphite to make pencil. It's safer. Because graphite is not that poisonous. It's like you are eating charcoal. Okay, it's not so poisonous as compared to what? To lead pencils or to lead. Okay, all right. So the next allotrope of carbon is charcoal. Okay, charcoal. And charcoal is the amorphous form of carbon. Is the what? The amorphous form of carbon. It is porous. When you say it is porous, it means that the molecules are permeable. Okay. The molecules are permeable. Water can easily penetrate it. Okay, that's charcoal for you. Charcoal absorbs gases because it's porous. It has a semi-permeable molecules or semi-permeable membranes. Okay, the membrane is semi-permeable. Let's say the membrane of charcoal is semi-permeable. It absorbs gas. Okay, it absorbs gas. That's why activated charcoal is used to manage gastritis. Okay, gastritis in medicine. Okay, so when you have too much gas, copious gas in your stomach or in your alimentary canal, you can use activated charcoal to abate the symptom because activated charcoal absorbs gases. So when you ingest it, it absorbs much volume of that gas, and maybe at the end you are going to have like let me say 30% of gas left. The charcoal must have absorbed up to 70% of the copious gas in your alimentary canal. All right. So what are the uses of charcoal? Charcoal is used as fuel. Many people use it and they cook. But the way we dey roast, now charcoal we take the roaster, and so on and so forth. So that's what we use charcoal for. Charcoal is also used for purification. What kind of charcoal is used for purification? Animal charcoal. Okay. Plant charcoal, that's the charcoal gotten from burning plant products such as wood and so on and so forth. Those plant charcoals are used for what? They are used for fuel. They are mainly used as fuel. Therefore, animal charcoal is used to purification. It is used to purify sugar. You know that sugar not the white too. After extracting sugar from sugarcane, sugar is not whitish, it is brownish. You now use animal charcoal to purify it, okay, in form of bleaching. You purify it and it turns white. All right. So the final allotrope of carbon is the fullerenes and the carbon nanotubes, okay, and they are the modern allotrope of carbon, okay. They are used in what? In nanotechnology. Now let's look at carbon 4 oxide as the most common oxide of carbon. What is the laboratory preparation of carbon 4 oxide? It is prepared by the action of dilute tetrasulfate 6 acid on limestone. When you react dilute tetrasulfate 6 acid with limestone, you get carbon 4 oxide. Let's look at the equation. When you react this hydrochloric acid, a dilute one, they might set concentrated one for you among your option. Pick dilute. Dilute one, you react it with limestone. You are going to get what? You are going to get calcium chloride plus water plus carbon 4 oxide. What are the properties of carbon 4 oxide? It is a colorless gas. It is odorless. It is tasteless. Carbon 4 oxide is heavier than air. It means that it's denser than air. Meaning that air can't carry carbon 4 oxide. Air no dey fit carry carbon 4 oxide because it is denser than air. So if carbon 4 oxide dey air, now air go dey up, carbon 4 oxide go dey down. Okay, so it is difficult for air to carry carbon 4 oxide up and down. Alright, because it's denser than air, it's heavier than air. So for air now, carbon 4 oxide go dey down, air go dey up. Carbon 4 oxide go dey down, air go dey up. Alright, so it is an acidic oxide because it's an acid anhydride. It dissolves in water to form what? To form acidic solution or to form an aqueous acidic solution. Alright, what are the uses of carbon 4 oxide? It is used to manufacture fire extinguisher. Remember, carbon 4 oxide, that gas itself extinguishes fire. It does not support combustion. Carbon 4 oxide does not support combustion. Carbon 4 oxide does not support combustion. Sink it into your head. It hates what? Combustion, or combustion hates carbon 4 oxide. Immediately fire the burn, now you carry carbon 4 oxide, spray for the fire, it go off. So that's the principle at which fire extinguishers functions. Okay, so inside fire extinguisher most of the time, see what they dey inside, acid and limestone. So immediately you activate the fire extinguisher, some acid is released onto the limestone inside the system, and carbon 4 oxide is formed as gas. So as you spray like this, you spray like this, you spray like this, it will quench the fire. Okay, it's extinguishing the fire. So carbon 4 oxide is also used for refrigeration. Okay, the one they call dry ice. It's also used in refrigeration. It's a cooling gas. It's also used in carbonated drink. Carbon 4 oxide is one of the most widely used preservative for drinks. Carbon 4 oxide. Okay, if you bubble carbon 4 oxide into water, it's going to make that water last longer. If you bubble carbon 4 oxide into a drink, it's going to make that drink last longer. All your Coke, your Fanta, your Lacasera, your Sprite, your 7-Up, your RC, your malt, your which other drink? Just name them. All those aerated drinks, carbonated drinks. Carbon 4 oxide is the major preservative. That's what they use in preserving the drink. All right. So in essence, carbon 4 oxide is used to extinguish fire. Carbon 4 oxide is used for refrigeration, called the dry ice refrigeration. Carbon 4 oxide is also used as preservative. Okay, it preserves carbonated drinks. All right. So let's look at the action of heat on triazocarbonate 4 salts. Let's look at the action of what? The action of heat on triazocarbonate 4 salts. So the action of heat on triazocarbonate 4 salt is when triazocarbonate 4 salt, which is this calcium triazocarbonate 4, is heated. What is formed? What is formed? It dissociates to form what? To form calcium oxide and carbon 4 oxide. This is what the thermal decomposition of limestone or the thermal decomposition of triazocarbonate 4. So if they ask you what is gotten or what are the products of the thermal decomposition of calcium triazocarbonate 4 or limestone, you are going to do the reaction now. You decompose it, carbon 4 oxide come out, calcium oxide come out. As simple as ABCD, all right. So what is the test for carbon 4 oxide? Very easy peasy. We already treated all the tests for all the common gases. Okay, all the gases we Jamb don't say the set. We don't treat all the tests for them. We even treat metallic ion. Do where to find the lecture in the playlist and take that lecture. No go lose guard this Jamb. No go lose guard again. Oh. This one another year. If you miss on this year, you go wait another full year again. 12 months no be beans. So 12 months no be shy play. All right. So the test for carbon 4 oxide is what? CO2. First of all, we are going to look at the test for what? Triazocarbonate 4 ion, which is this. All right, triazocarbonate 4 ion. When you add acid to the solution in question, what happens? Effervescence occurs, and that effervescence occurs as a result of the release of CO2. All right, a result of the release of CO2. What is effervescence? Effervescence is when gas leaves a substance so fast. For example, you carry limestone. Okay, or you carry calcium carbide, the one where they call carbide, you spit, put, tear, or you pour water, you notice that will make gas will come out. Okay, carbon 4 oxide will come out. Okay, so when a substance, a chemical reaction occurs, when a substance is added, maybe especially when you add water to the substance. Okay, when water is added to a substance, that chemical reaction that occurs, okay, gas is going to be given off. It's very rapid. You are going to hear something like shh, that's effervescence. Okay, gas is given off. Okay, as a result of when you add water to an effervescent substance. There's the kind of substance called effervescent substance. Okay, any substance that go effervescent is called effervescent substance. All right. So when you add water to an effervescent substance, it makes gas is released. Most of the time, it's usually carbon 4 oxide. Most of the time. All right. So that's effervescence for you. Let's look at the test for hydrogen triosocarbonate 4 ion. Okay, that's the acidic ion. Let's look at the test. It is the same thing with the carbonates. Okay, the same thing with this triosocarbonate 4 ion. Okay, but it is weaker. The effervescence is weaker. When you add the acid, the effervescence is what? Weaker. All right. Now let's look at the test for the carbon 4 oxide. The test for the carbon 4 oxide is that it turns what? Lime water milky. What is lime water? A solution of lime. A solution of lime. So immediately you bubble carbon 4 oxide into a solution of lime. What happens? It turns milky. And why does it turn milky? Because limestone is formed. Calcium triosocarbonate 4 is formed. Let's look at carbon 2 oxide. This is the lower oxide of carbon. Okay. The second most popular oxide of carbon is the carbon 2 oxide. All right. So what is the laboratory preparation of carbon 2 oxide? The laboratory preparation of carbon 2 oxide is through what? The heating formic acid with concentrated tetrasulfate 6 acid. Or you can also use this style, incomplete combustion of carbon. Like I always tell you, when you burn a substance, okay, when you burn a substance in the presence of much amount or sufficient amount of oxygen, that substance is going to form the gas of that substance, is going to form the higher oxide of that substance. So when you heat a substance in the presence of sufficient amount of oxygen, that substance is going to form the higher oxide of that substance, or the higher oxide of that substance is going to be formed. But when you heat the substance in the presence of, or you burn the substance in the presence of limited supply of oxygen, the lower oxide of the substance is going to be formed because the oxygen is limited. Remember, oxygen is required to form oxide. So because the oxygen is limited, the lower oxide will form. That's what we have here. When you burn carbon in the presence of sufficient amount of oxygen, it's going to form the higher oxide of carbon, which is carbon 4 oxide. Why does it form the higher oxide of carbon? Because oxygen is sufficient, okay, to form higher oxide. But when you now burn carbon in the presence of insufficient amount of oxygen, okay, poor oxygen supply, you are going to get the lower oxide of carbon, which is carbon 2 oxide. So it's also a method of preparing carbon 2 oxide, okay, through what? Incomplete combustion of what? Of carbon, okay, and you know that carbon is present in fuels. All right. So what are the properties of carbon 2 oxide? Carbon 2 oxide is colorless, it is odorless, it is also tasteless. It is highly poisonous, very poisonous, especially to mammals, okay? Very poisonous, especially to mammals. It's poisonous to mammals because it binds with hemoglobin and affects, it alters the respiratory pathway. So I have explained the cascade, the process of how carbon monoxide affects the respiratory pathway and leads to death. I have the lesson in the playlist. Do well to access that lesson and take it. Jam the set question from there. Well. So what are the sources of carbon 2 oxide? It forms from charcoal fire, when you burn charcoal fire, and car exhaust fume. Why does it form in the car exhaust fume? Because the combustion that occurs in cars occurs inside the cylinder of the engine in an enclosed system. Okay, enough oxygen no dey reach there. Now make carbon monoxide dey form. But if you burn fuel in the atmosphere, it's going to form carbon 4 oxide because there is sufficient amount of oxygen. Okay, because that in cars occur in a closed system, it leads to the formation or the liberation of carbon 2 oxide. So what are the effects of carbon monoxide on blood? You know, see and say Jamb, don't put them, say make you read and make you know, because there is set question for there. Well. When carbon monoxide binds with hemoglobin in the blood, it forms carboxyhemoglobin, this compound. And this compound is more stable than the hemoglobin itself. Okay, because the hemoglobin reacts reversibly to give out oxygen, okay, and it goes to absorb more oxygen. When it gets to the cells, it's undergo a reversible reaction, it reverses the reaction and oxygen is released and the cell respires. So that's the normal pathway. But when it forms this carboxyhemoglobin, it is more stable. When it reach time to carry out the reversible reaction, make oxygen enter cell now, it no go green happen. Carboxyhemoglobin go there, the cell go starve the cell of oxygen. And this prevents oxygen transport. You can't transport oxygen throughout the cell. And this leads to what? Suffocation. And eventually what? Death. Now, let's look at coal. Okay, coal as a compound of carbon. Okay, what are the types of coal? We have the peat, we have the lignite, we have the bituminous, we have the anthracite, and these are arranged according to the increasing carbon contents. Okay, the peat has a lower carbon content than the lignite. The lignite has a lower carbon content than the bituminum. The the bituminum has a lower carbon content than the what? The anthracite. And among this list, the lowest carbon content is the pyat, while the highest carbon content is the what? The anthracite. All right. So ensure you know the lowest and the highest. The lowest is the pyat. The highest is the what? The anthracite. All right. So the destructive distillation of wood forms some products such as charcoal, tar, and pyroligneous acid. These three products are the products formed from the destructive distillation of wood. Okay, destructive distillation. So let me just tell you, Jamb said you should know this thing. That's why I put it here. Okay, so ensure you know them. Have a glance so that when you see them as part of your option, you will be able to, as in, find the answer. If you too much, use elimination method and you pick the correct option. All right. So from the destructive distillation of wood, you get products such as charcoal, tar, and pyroligneous acid. What are now the products formed from the destructive distillation of coal? Remember, we just looked at the destructive distillation of wood. Now we are looking at the destructive distillation of coal. What are the products formed? The products formed from destructive distillation of coal is coke, coal tar, ammonia liquor, and coal gas. Coke, coal tar, ammonia liquor, and coal gas. 4 products from destructive distillation of coal. All right. Now let's look at coke. All right. All these are industrial gas. Okay, such as synthetic gas, for example. You have producer gas. You have many of them. Okay, industrial gases. All right. So in gasification, coke reacts with steam to form what? Carbon 2 oxide and hydrogen. And this is called what? Synthetic gas. So Jamb can ask you, coke reacts with steam to form what? The answer is synthetic gas. It's an industrial gas. Okay. Or synthetic gas contains what? You already know now that is what? Carbon 2 oxide and hydrogen. Know all these things. So Jamb be asking where. All right. So what are the uses of coke? All right. Coke is used as fuel in blast furnace. You know what blast furnace is used for? Okay, to roast metal. Okay, to roast ores. All right, in blast furnace. All right. So coke is also used as a reducing agent in metallurgy. All right, it's used as a reducing agent in metallurgy. All right. So coke is used in the manufacture of what? Synthetic gas, which contains carbon 2 oxide and hydrogen gas. Let's look at synthetic gas itself. What is the composition of synthetic gas? It's an industrial gas and it contains carbon 2 oxide and hydrogen. All right, and it is used in the production of methanol, ammonia, hydrocarbon, and the process whereby this synthetic gas is used to manufacture this methanol, ammonia, and hydrocarbons is what? The Fischer-Tropsch process. The Fischer-Tropsch what? Process. I think this process was named by a German. Now that we have understood carbon and its compound and everything that has to do with the industrial gas is listed, make sure you know this industrial gas, synthetic gas. Now only in Jamb put for the syllabus. So that may you just get the answers. May you not to stress yourself, the read things when you get ahead, when you don't go see inside your exam hall. And they give you what you go see inside your exam hall. So let's test the knowledge we've acquired so far by, looking at some Jamb must repeat questions and measuring how prepared we are for Jamb UTME 2026. Jamb must repeat questions. Question 256. Which allotrope of carbon is the hardest natural substance? A. Graphite. B. Diamond. C. Charcoal. D. Fullerene. What's the answer? Drop the answer in the comment section. I just taught you now. Question 257. Which allotrope of carbon conducts electricity? A. Diamond. B. Graphite. C. Charcoal. D. Coal. What's the answer? I just taught you. Please don't disappoint me. Drop the answer in the comment section. Question 258. Which reagent is used in the laboratory to prepare carbon 2 oxide? A. Sodium hydroxide plus sodium chloride. B. Hydrochloric acid plus limestone. C. Tetrachloride 6 plus sodium triazonitrate 5. D. Ammonium chloride plus sodium hydroxide. What's the answer? Drop the answer in the comment section. I taught you this thing now. It's very easy. Please give me the answer in the comment section. Question 259. Which test confirms the presence of carbon 4 oxide gas? A. Turns lime water milky. B. Decolorizes acidified potassium tetrazomanganate 7. C. Rotten egg smell. D. White fumes with hydrochloric acid. What's the answer? Drop the answer in the comment section. I already taught you now. What you wait for? Question 260. Which gas binds strongly to hemoglobin and prevents oxygen transport in the blood? A. Carbon 4 oxide. B. Carbon 2 oxide. C. Ammonia gas. D. Sulfur 4 oxide. What's the answer? I just taught you. Please drop the answer in the comment section, my scholar. Question 261. Which products are obtained from destructive distillation of coal? I told you. Say Jamb, they set and where. A. Coal, coal tar, coal gas, ammonia liquor. B. Charcoal, tar, pyroligneous acid. C. Diamonds, graphite, charcoal. D. Methanol, ethanol, and propane. What's the answer? Drop the answer in the comment section because I taught you. Don't disappoint me, please. Question 262. Which reaction produces synthetic gas? A. Coal plus steam gives you carbon 2 oxide plus hydrogen. B. Limestone decomposes to form calcium oxide plus carbon 4 oxide. C. Ammonium chloride plus caustic soda gives ammonia. D. Sodium triazonitrate 5 plus tetrasulfate 6 gives triazonitrate 5. What's the answer? I taught you. Please drop the answer in the comment section. Question 263. Which allotrope of carbon is used in making electrode? A. Diamond. B. Graphite. C. Charcoal. D. Anthracite. What's the answer? Drop the answer in the comment section. You were taught now. I just taught you now. Please don't disappoint me. I beg you. Let me see the answer in the comment section.